Hey, you guys, good morning.
Good morning, Dr. Jones.
How are you guys doing?
Good. How are you?
If I make it through this week, I hope you're doing great. That's how it's looking right now. But no, I'm actually doing pretty good. I'm just trying to get everything typed up and trying to finish up the semester. So I'm just trying to get that in, and you're trying to make sure you got everything together. So I'm just trying to do that last push. So, all right, chapter 18. Um, we're just going to finish up chapter 18 for today. And when we finish up chapter 18, that's all what I'm going to do today. We'll do, I'm going to see if I'm going to get started on 23 today. But I think I'm just going to end with chapter 18 today. And then, because I need to type up a few of the classes, y'all need rubrics and stuff, and I need to sit and type those up. So I need to do it while the kids are at the babysitter right now. And so this will be my only chance I get to do that. So I'm going to type all those up and try to get those up and loaded. And then we'll finish up chapter 23 next week. And then any other presentations or things that need to be done, I'm just going to record them and upload them. And then you guys can watch them at any time. They're just from the last few chapters. I was just looking at them. Just a few highlights that need to be on the exam that I have to talk about. So that's basically it. So I'm going to make sure I highlight those. I don't know if anybody else is coming on or not, but I'm going to go ahead and get started so that we can go ahead and end a little early, since we only got about 25 slides to do here. Where we left off from Monday is talking about aldehydes and ketones and what they actually do. And so I just wanted to go back and just make sure. So you really have acid catalyzed hydration, and we've really been talking about electrophilic and neutrophilic attacks. And the last few things that I really want to talk about when it comes to the carbonyl chemistry, because I'm going to focus a little bit on that, and it's a big section on carbonyl chemistry, is really looking at what happened to the carbonyls. So you know that aldehydes and ketones, they have the one carbonyl group. There are other chemicals that are out there that has more than one carbonyl group. So we're going to take a look at this from chapter 18, and then we're going to look at the amines in chapter 23. And chapter 23 will be the last chapter that I go over face to face with you guys. I will be, when we be meeting for the other classes, we're going to be talking about highlights of what you need to be focusing on for the exam. So I'm going to put together a series of different things that you guys need to look at, what you need to focus on for the exam, and talk about all of those and where you find them. Go back and look at those in the book and everything. So on Monday, after you guys have your last exam next week, we're going to focus on basically reviewing and everything, and you guys doing your projects. And so that's what I want to do with that. So acetyl formation. Aldehydes and ketones react with two equivalents of alcohol to form acetyls. Acetyl formation is catalyzed by these acids. Note, one thing that I want you guys to remember, acetyls are not ethers. Now, what you can have is, you can have a diol such as ethylene glycol, and is used in place of 2 equivalents of any type of alcohol. You can get a cyclic acetyl that forms, and that's what you see there, ethylene glycol, and then you react it with that hydroxide, and then you get the a cyclic acetyl and water. Now, with the diol formation, the synthesis of the acetyls can be reversible, and the equilibrium favors the reactant. But in the acetyl synthesis, water is formed as a byproduct. Equilibrium can be driven to the right by removing the water. And you can do that in form of distillation. A lot of people doing that. So when you doing this and driving the chemistries to the left or to the right, when you driving those equilibriums, that's an application of the LeChâteau's principle. So that's where you get to see it at. I know we talk about it in General Chem 1 and 2, especially in Gen Chem 2, because that's what my students are going over in that class. But you see the applications of that throughout chemistry. Now, when you have this, you can have hemiacetal formation too. The mechanism for when you forming these acetals can be broken up into 2 groups, 2 parts. And then the first addition forms the hemiacetal, and that's what you see there. You do part 1, and then when you go ahead and do part 2, it forms the acetal. So what happens with that? So basically the protonation of the carbonyl oxygen, it forms what you call this resonance stabilized cation. So it's stabilized, and then what happened is you have a nucleophilic attack on that alcohol, and then is deprotonation form the hemiacetal. So that is what happened during the hemiacetal. So you're going to form that carbonyl oxygen. It's going to form a cation, but that nucleophilic attack is going to come there. Now, the second part involves the conversion. So you convert it from the hemiacetal to the acetal. And so what happens is the first 3 steps deals with mainly the acetal, or first 4 steps deals with the hemiacetal, and then 5 through 7 deals with forming that acetal group. So what you happen is, step 1 through 4 deals with the hemiacetal, and then 5 through 7 deals with the acetal. So what happens is you have to protonate that OH group of the hemiacetal, and that forms a really good leaving group. And then the loss of water forms that stabilized cation again. It starts again, and then you have that nucleophilic attack followed by the loss of proton that forms the acetal. The overall result of part 2 is the addition of the second alcohol group to the carbonyl. So that's what happens. Now, what can you do? Because the conversion of an aldehyde ketone to acetal is reversible, the acetal can be hydrolyzed to an aldehyde or ketone by treatment with a particular type of aqueous acid. So the reaction is also an equilibrium process. It drives to the right with the large excess of water for hydrolysis. So you can take the acetal, put a lot of excess water in it, and drive it, and then whichever, because basically what's going to happen is you have that acid in there, and usually you'll have a low molecular acid, because most of it is water, and it'll drive it right back to its starting material. So that's where you can go in between it. What is the application of this? You can look at this when medicine is going into the body. It drives it for a certain way, and then it converts back to water for you to basically secrete it out, like sweat, um, urine, different things like that. Certain medicines that you take, it'll go back and forth. So you can see that, and that is what really happens. So that's the purpose of some acetyls, is just you want to shift it for a little while, then shift it right back. Now, acetyls are valuable because they are protecting groups for aldehydes and ketones. Now, how can you do that? Sometimes you can have it to where you can have acetyls as a protecting group for aldehydes and ketones. And then when you have those, what happened is you want to just say you want to reduce an ester to an alcohol, but you want to leave the ketone there for another reaction. Because the ketones are more readily reduced in a lot of cases, methyl 5-hydroxyhexanoate is formed instead. To solve this problem, you use a protecting group to block that ketone carbonyl. So that's what you do. So sometimes when you have them in there, what happens is, and this is what happens, you see here at the bottom, that carbonyl group. So the ketone, so you got your aldehyde in red, you got your ketone in blue. Your ketone is more reactive, and that's because that aldehyde have a little bit more stuff attached to it, so it's not as reactive. Now you want the 6-hydroxyhexatunone, that's what you want, but what'll happen is you'll do this reduction, and sometimes it'll forms there. So you have to use a selective, you have to use a protected group to make sure that ketone don't form. Now, when you're doing that, you have to protect and then deprotect. That's what you have to do. You have to protect the interfering functional group. And in this case, it's the ketone carbonyl. You carry out your desired reaction, and then you have to remove the protecting group. That is what happens. Let's just say, just plain and simple, you have a urinary tract infection. So there are certain things that you have to take in order to clear that infection out of your body. But what happens is sometimes when you have a urinary tract infection and when you take in certain medicines, it'll clear everything out of your system and leave you very weak. And sometimes what they do with drugs, they put these other groups in there that protect other things, so other minerals and stuff will not come out in your urine, or not as much of it. Sometimes it will still produce certain things, like let's just say if you get it, but you want to make sure you keep your sodium up, your potassium up, because we can urinate those out. For example, women, when they, especially when they get pregnant, they can't lose a lot of potassium and stuff. So what you want to do is have the medicine to take so it can protect certain things and keep certain minerals in the body while getting rid of the other stuff. Because as you guys see and know that, different types of medicines will give you adverse reactions and all these different types of side effects. So this is what's happening here. So you want a desired product. Sometimes you're going to get that other product, and sometimes you won't get it in the amount that you get it in. And so that's why you got to have, and when it comes to medications, they have to be highly selective. Now, what about the cyclic hemacetyls? They contain 5 and 6 member rings. They are stable compounds, and they can be isolated pretty easily. what do each one of them have? So what's the difference between the hemiacetal and the cyclic acetal? Uh, Basically, each carbon is bonded to an OH group and an OR group that is part of the ring. So that's what it is, because it is bonded to other things. That's why they easily isolated. Whereas the hemiacetal, it just got one carbon bonded to an OH group and an OR group. So because of the ring, it makes it more stable, and it can just be isolated pretty easily. Now, how do you form these? Um, they can be formed by intramolecular cyclization of hydroxyaldehydes. So yeah, you have hydroxyaldehydes. And then, so let's look at this. You got 5-hydroxy pentanol. And then what you can do is basically when you hydrolyze it, basically you can get 94% of a cyclic um, um, hemiacetal. So the intramolecular reactions to form are faster than the corresponding intermolecular reaction. Two reacting functional groups, that OH group, that hydroxide group, and that double bond carbon oxygen, are held in close proximity, increasing the probability of the reaction. So we talked about, this is talked about a little bit in Gen Chem 1 and 2, but what you have to do, those bonds have to be in close proximity. And when they're in close proximity, that what makes the reaction happens faster. So they have to be in close proximity. Now, when you have hemiacetal formation, it is catalyzed by both an acid and a base. So listen to me about that. When you have acid catalyzed hemiacetal formation, it is catalyzed by acid and by a base. Now, with intramolecular and hemiacetal formation, the intramolecular cyclization of a hydroxyaldehyde forms a hemiacetal with a new stereogenic center, so that equal amounts of two enantiomers can result. So this is what happens here. So you have that, and then you get that new stereogenic center. Because that one still forms, you can have two enantiomers that come out of that. Now, cyclic hemiacetals can be converted to acetals by treatment of alcohol and acid. And then what happens is that hydroxide group is transferred into the OR group of the acetal. So that's what happens. So basically, that hydrogen is going to protonate and go away and form water. So that is what happens there. So you got your hemiacetal, and then you treat it with an alcohol. In this case, they treated it with methanol. And then when they treat it with methanol, it goes away and you got your acetal plus water. Now, a cyclic acetal from a cyclic hemiacetal, it goes through those same steps pretty much. The difference is not that much of a difference. You got protonation of the OH group of the hemiacetal, and that forms a good leaving group, so that still stands. The loss of water forms that stabilized cation, there again, resonance stabilized. And then the alcohol does that nucleophilic attack. And then it's followed by loss of protons. That proton forms the acetal. So that's what happens there. Now, with this, what happens with the hemiacetals to acetals, the overall group replacement of the hemiacetal it goes from OH to OCH3. This reaction happens really fast because the carbocation formed in step 2 is stabilized, making the hemiacetal group different from the hydroxy group in other alcohols. So when this happens, basically what's going to happen is when you react it with the alcohol, only the hemiacetal OH group is going to react. That's pretty much it. So when you see it here, it just one of those groups are going to react, the hemiacetal one. So the one at the top is going to react. The OH at the bottom, that hydroxide group, is still there. So it's not going to react. Now, one of the things we're going to look at, and when you guys go into, for those of you who are already in biochem, I'm going over some of this with them now, but carbohydrates is one of the things that you're going to see. Carbohydrates, they're sugars, starches, they polyhydroxy aldehydes and ketones. That's what carbohydrates are, or compounds that can be hydrolyzed to them. Now, carbohydrates, most of them contain cyclic acetyls or hemiacetyls. Now, examples of those are glucose and lactose. So those are the ones that you mostly see. Cyclic acetyls or hemiacetyls is formed in glucose or lactose. So glucose, you know where that comes from. Lactose, major component in milk. Now, hemiacetyls and sugars are formed by cyclization of hydroxyaldehydes. Now, with that, the hemiacetal and glucose is formed by cyclization of an acyclic polyhydroxide aldehyde. You see that in A, and then it's shown. So basically, when the OH group on the C5 is the nucleophile, cyclization yields a 6-member ring. Cyclization, most of the time when you have that, forms a new stereogenic center. The new OH group of the hemiacetal can occupy the equatorial or axial position. That is what you see. With this, I am going to probably stop right here. When it comes to carbohydrates, we are going to look at that when, especially you two, when we get to biochem. So the people that are in biochem, they are actually restarting on carbohydrates now. That's something that the last part of biochem we're going over. I am going to stop right here. We're going to cover chapter 23. Let me, hold on just a second. Let me pull it up and take a look at it real quick. We got a little bit of extra time. I may start it, but I definitely won't be able to finish it. Oh, yeah. Oh, I think I better start it because it is a lot for that chapter. So that chapter has a lot in it, and I have to make sure that I have assigned that one on the homework. But this is the last one that we're going to do. Hold on just a second. Let me share that. Because that chapter is a long chapter. I didn't realize how long it was. I thought it was more so 80, but it is a lot of slides. So this chapter is a long chapter. Hold on just a second. I didn't do something right. Let me close that out. I'm going to reopen it in just a moment. Okay, I'm going to get started, but I am definitely not going to finish all of chapter 20 of 23. This is one of the ones I did really want to go over because amine chemistry is very important. And looking at it, um, just want to check something. Okay. Just trying to check something right. I'm trying to make sure I have went over everything. Let me see. Okay, so with this is a big chapter, so I'm gonna do a few slides, but we gonna hit this hard next week. Um, I just want to introduce what are amines. These are organic nitrogen compounds. Uh, they have ammonia in it with alkyl or aryl groups. Amines, they're classified 1, 2 degrees, or 3 degrees based on the number of alkyl groups. So bonded to the nitrogen. Amines are strong bases and they are good nucleophiles than other neutral organic compounds. This is part of the reason why I'm going over, because you talk about nucleophilic reactions in chemistry. So I wanted to make sure I touch on that. The amine nitrogen has a non-bonded electron pair, making it both a base and a nucleophile. As a result, amines react with electrophiles to form these ammonium salts and compounds with 4 bonds to nitrogen. So that is what happens. This is an electrostatic potential map of the amines. And there's some 3D structures of them. It's sp3 hybridized. Amine nitrogen has 4 different groups. Around it, it has a stereogenic center. And then chirality can be ignored because 2 enantiomers interconvert by passing through a trigonal planar achiral transition state. So I'm going to stop right here with this. We're going to pick this up. Chapter 23 is going to be a very long chapter. So even though I wanted to start on it today, um, I just want to introduce you to it to make sure you have all of that. Like I said, I'm going to go through and check and see. This is the last chapter I'm going to go into before you guys' last exam. There's a couple of other chapters that I'm going to want you guys to look at. Um, and I'm going to combine those chapters together, and I'll pre-record those. But this is the last one that we're going to go over from the book in person. The rest of them, what I'm going to do when we meet, I'm just going to highlight those, just what you need to look for and what you're going to be expecting on your final exam. You guys have a good one. If you got any questions or anything, send me an email. I'm going to try to work on getting all the things typed up for your rubrics and get that finished up so y'all know what to turn in and when to turn it in. You guys have a good one. I will meet with you guys on next Wednesday. We're going to get chapter 23, try to get it knocked out as quick as possible. You guys have a good weekend. Stay safe, and I will talk to you guys later.